So the world is going electric. And batteries will do for electrification what the refrigerator did for food. Because batteries will allow us to move clean energy through time and through space. We don't have a problem with the availability of energy on this planet. We have a problem with getting this energy to where we need it and when we need it. But if we approach battery manufacturing the wrong way, we will end up repeating mistakes from the past. Mistakes that are at the heart of the climate environmental crisis that we see today. And that's what I'm here to explain. It's all about the way we are using the Earth's resources. So historically and today, we have been mining oil from the Earth crust with little concern to the long-term effect. And this example of how we've been approaching the fossil fuel industry and how we've been dependent on it, how we have been extracting oil where it's economically possible, refined it, burned it, and it ends up in the atmosphere. That's the perfect illustration of the fundamental, simple, and linear model that we are working with: extract, use, and discard. When I was a professor in environmental engineering, I used to teach my students that mistakes are okay, as long as you learn from your mistakes and as long as you take action. So now, when we are evolving, when we are changing, when we are building things from scratch, we should think twice, and we should do it right this time. And what does this mean for batteries? There are two things we need to know about batteries. One is they require enormous amounts of energy to produce. And the second is they're made from minerals, minerals that requires global mining, refining, and processes in long and complex supply chains. So if we start with energy, a battery factory is a very large and complex operation. It requires large amounts of heat and electricity to produce. It starts with a chemical plant, then follows long coating machines. After that, we have cell assembly, which is fine electronics equipment that require clean and dry rooms. Now, in the end of this process, each and every battery cell needs to be charged and discharged in certain patterns to gain its properties. And if we put this kind of factory under a fossil fuel grid, we will end up with a carbon footprint, which is the benchmark today, which is around 100 kilograms of carbon dioxide per kilowatt hour produced battery. And how much is that? That is, if we take it at scale, so 20-30 years production of battery manufacturing will give the total footprint about half the size of Germany. Now, that would be a big mistake. Luckily, you can slash that footprint with some 67%. That's 2/3 if you put the same operation on the renewable energy grid, which we do in northern Sweden. That, on the other hand, leaves us with the remaining footprint, the last third, coming entirely from everything that is outside the factory, and the lion part from the supply chain. And that leads us to the second topic we have to talk about, which is the minerals. So batteries are made from minerals that, for example, nickel, cobalt, and lithium. And the way we approach this is going to determine how much we can further slash that carbon footprint. Luckily, if we put it under this renewable grid, if we approach it the right way, with sustainable mining and a lot of recycling, we can significantly reduce the footprint. 1 ton of lithium, battery-grade lithium, requires 750 tons of brine, or 250 tons of lithium ore. Same with cobalt. If you need 1 ton of battery-grade cobalt, you have to mine 300 tons of cobalt ore. So, does this give us a similar situation to the oil history we had? No, because the difference is that when we mine metals, they are elements. And if you can get elements back to their elemental form, they are just as good as new. And this is the fundamental difference between the combustion engine history that we're living now and the new electric vehicle industry. Because at the end of the life cycle, you can bring the metals back from the market and you can use them again and again. So what we have developed at Northvolt is a recycling process where we take the batteries back from the market, we discharge them fully, we take away the aluminum casing, we take away all the cabling, and then we take out the cells and the modules. We take those cells and modules together with some waste material we have from the production, and we throw it into a big shredder. We chop it up. We take out the foils, the copper foil, aluminum foil, some plastics, and then we are left with something that we call the black mass. And this black mass is a fine black powder. And this fine black powder consists of everything that we had coated on the electrodes in the factory. It's the graphite from the anode, and it's the nickel, cobalt, manganese, and lithium from the cathode. We take this fine powder, the black mass, we pass it on into the hydrometallurgical process. Hydrometallurgy means treating metal in liquid. And what we do is that we use different pressure changes, temperature changes, and pH to separate them from one another. We refine them so we get them into the form that we need for the production. Salts for nickel, cobalt, and manganese, or hydroxides for lithium. And then we do like this. We send them across site straight into production. So what we have is a circular battery economy. And this is the fundamental difference between the combustion engine industry and what we are building now. We should do this not only for batteries. We should do it for wind turbines. We should do it for solar panels. We should do it for all the new industries that we need for this transformation. And we're gonna, thank you. And we're gonna have to accept mining as part of this transition, absolutely. But when we are taking things from the earth crust, when we are borrowing from the future generations, we have to do it responsibly, and we have to make sure that we can use these materials over and over and over again, because fundamentally, we can. And we should not only build recycling processes and a port for the materials when they come to their end of life, we should also build accounting and traceability system so that each car maker can follow up and trace how much they can further slash their footprint by sending the batteries back at the end of the life. And why we are doing this, I'm sure you already figured this out, it's not only environmentally beneficial, it's also, of course, economically profitable. Because by doing this, the material sustains its value through the lifetime. And this altogether may sound a little bit hard, it may sound a little bit complex, but if we get this right, it will be rewarding on so many levels. And I can tell you that the young generation of talents, of engineers that we hire today, they understand all this, and they ask nothing less from us. So with that said, I just want to say to all of you who listened, and I also want to say to all the people who packed their bags and moved up to the Nordics, who are fighting every day to make this happen, thank you.